which is about 500, maybe I'm wrong. So that's quite a bit of chunks. So here we have this ticking command block here showing us the time. And if we move out, as you can see here, we have here on the X, our coordinates are raising. And the command blocks is actually stopping when we move more than 64 blocks away. So I actually experimented a little bit and find out that all the events in the game, including mob spawning, blocks ticking, even command blocks, are only executed within 4 ticks around the player. And the rest what we see, regardless of our render distance, in this case we have 12, so quite a bit. We can see, for example, these contraptions over there are not even processed, or nothing happens there. So a little quick note, because I've heard people comparing performance of Java Edition and Bedrock Edition, saying the Bedrock Edition is much smoother, but it makes the Java Edition injustice. Obviously Bedrock is performing better because there is nothing happening here, unless it's very close to the player. As I just said, with typical scenario, the random distance of 16, Java version has to deal with about 20 times more stuff than in the Bedrock Edition. Obviously Java Edition would perform much better if it would only take the area just near the player, but everybody would be quite pissed because then my contraptions are not working, my farmers are not working unless I babysit them. So regarding the redstone system, let's switch the command type here from repeating to impulse and check this out. This is actually really interesting. Did you notice anything suspicious? Let's do the same experiment in Java version. Okay, I'm flicking the lever or lever, whatever. You can see we can only see even numbers. So our first suspicion here is that regardless of the fact that the game runs on 20 ticks per second, the entire redstone system runs actually on 10 ticks per second, regardless of the cases. So what we have here, and that's my suspicion, is unlike in Java where every single action meets a reaction right away and it's organized in those ticks and multiple events can happen even within the same tick, and we can control, for example, how pistons behave within the same tick. And that's how we can have those cool 0 tick and 1 tick contraptions. In this case it may not be the case, and to prove it we have another experiment here with water. So in Java, water spreads exactly 5 ticks per block. So in a second, water spreads exactly 4 blocks. And judging what I see here, it's probably the same thing. So here we have a little water channel, and here the dispenser can dispense water into this block, which can spread to the following blocks. And we have here 2 rows of observers, and those observers, one of them run into the command blocks, and we have our time query command block over there. And on the right hand side we have dispensers or droppers, whatever. And those are just to notify us orally about what happens. So let's listen carefully what happens if I send that water out. Okay, so let us hear this in Java Edition. Anything suspicious? First of all, in Java it was very rhythmic, like tick 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 tick, because we have those 4 actions per second and they happen exactly 5 ticks apart. In Bedrock, if we have this 2-tick resolution, then the water spreads for every 5 game ticks, but the observers and dispensers can only react with this 2-tick resolution, and that's why we had on the left hand side, I can repeat that. We can either have 4 or 6 ticks apart. And if we listen closely, we have this rhythm. It's not really even, it's like pa-pam, 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 pa-pam. Yeah, and this is actually a proof that the entire redstone system actually runs specifically on 10 ticks. And that's actually pretty mad, because in Java we could extend and retract the same piston or multiple pistons within the same even game tick and be able to very quickly move blocks and do stuff. Even within 1 game tick it was possible to do a lot of interesting things. Here nothing happens, like all the inputs are probably collected within 2 ticks, one after another, and then they're being processed and something happens and then they are being executed after those 2 game ticks, which means that nothing can happen actually instantly in this version, even with observers. So everything happens, every event's inputs are collected for those 2 game ticks, block ticks, whatever, and then they are being executed or acted upon in this, what we can call here a redstone tick. Okay, so let's test here a little bit of the basic redstone timing things. So we have here, for example, repeaters, so what you'd expect, 2 ticks apart. All the other basic components probably you'd expect to work the same way. Next we have pistons. It's actually a very important change. So in Java Edition they extend in 3 game ticks and they react to retraction instantly. So we have 3 or 0. And here in Bedrock we have 6 game ticks, so 3 what we call redstone tick. So that's twice as slower, and if we retract them, they are not instant, they are 2 ticks apart. So yeah, so this is much different than with Java Edition. And what we have next is observers. Observers react instantly. You can see that all the blocks that change the state, or at least they should have changed state here, which is obvious cases they work. We can see that it doesn't actually react to the dropper changes. So what would happen if we would phase 2 observers into each other, which in Java makes a really cool and modern clock. So we have this clock here that ticks very fast. We cannot even see what it does. So if I put, for example, dust here, you can see that's always on. But see what will happen if I, for example, place an observer here. See, it actually stays on, and it's because of this one being kind of bugged out. See, I place another observer, they're on. If I turn this off, see, they're all on. Although this observer here, they actually work. So this is just a visual glitch, and it will go off after some time by itself. So after our brief experiments with the loaded area around the player and also the redstone system, we can look into some practical solutions. So item elevators, that's something really important. In Java, recently this kind of elevators got their official support, in the sense that now items when dropped inside the blocks will slowly elevate towards the top, which makes it for a very simple item elevator. Unfortunately in Bedrock, if I put a bunch of items here and close that in, you can see items are not flowing anywhere. So this kind of elevator is no good. We have to use actually dropper elevators. So this is a standard item pipe type elevator. It's simply we grab the output from that bottom dropper with a comparator, run it into a clock. In Java we just need to staircase it up like that. In Bedrock we actually have to point it into the dropper, which means that we have to run a separate signal to the comparator to the side in order to make a clock. Nevertheless, this actually item pipe type elevator works, and if we drop items here, you can see it's silent and it moves up items to the top. Why it's an item pipe type? Because items are actually getting stuck temporarily in these droppers on the way, because all those droppers are powered exactly at the same moment, which means that they move one element from the bottom dropper and they move them kind of in jumps up to the top one. So this would be like a very good solution if, for example, we have a farm and we just want to collect our drops and we don't care that 1 or 2 or 3 or whatever are being stuck permanently here, because they will be moved eventually with other stuff. So this works in Bedrock, no problem. Next is the proper elevator, and that's the design I was using for quite some time recently. If you put even a single item here in Java Edition, it will always and silently be up in the top container. However, as you can see, nothing happens, and this is actually because of the lack of quasi-connectivity. So the key to silent elevators, like proper elevators, is the fact that in Java Edition, with a single torch, we can power 2 droppers at the same time, and based on the processing order of those droppers, item is always processed first from the bottom dropper, goes up, then another torch activates another 2 sets of droppers and the item goes bam bam, and so on and so forth. So we can actually have a proper silent elevator in Java thanks to the quasi-connectivity. In Bedrock it's a different situation, because in this case this torch actually powers only this dropper and not the dropper below it. So why no items are moving is because only every other dropper is being powered in this sequence. However, if we power the medium dropper directly, for example through a redstone dust or repeater, it powers not only that dropper but also dropper below it and above it, so 3 droppers in a row. And because of what seems to be a random processing order of those events, then it's not very reliable which dropper will actually act on it. So as you can see, I've been trying here to build some sort of an elevator that would run on this principle, but it just simply didn't work, probably because of the update order. So after very much so deliberations and tries, and I actually gave up on it, and this is actually the elevator, still the item pipe type elevator that actually is infinitely expandable. So we start exactly the same as at the beginning. So we have here a comparator, runs into a clock, and then we grab the same signal and runs it across, like cycling back and forth, so all those droppers will power exactly at the same time, which means that an item that's in here will eventually make its way up And then when you run out of signal, we just make this kind of a bracket. The bracket has to go one up, so because this will be a different tick. So this dust here powers these through droppers, 1, 2, and 3. And this dust over there from the next sequence, because it's in different section, actually powers these 3 droppers, and then the signal repeats. So as we can see, if we turn it on, this actually works. We can send items silently up to the very top as much as we want. So we can actually make this infinitely expandable. So let's switch to another topic. So since pistons are not dropping blocks in Bedrock, plus observers are actually immediate. This was actually one of the 1.11 snapshots. I think it was 1.11 with observers. There's a really cool feature that you can build this kind of really funny looking double piston extenders that actually worked, and the application was clear in, for example, 2x2 tree farms. But because we can clearly see, yeah, 2x2 trees and it don't grow in Bedrock. There's no 2x2 trees. But if there ever are 2x2 trees, this is the solution that one can be used. It's very easily tileable up in terms of to make a 2x2 tree farm. So for example, if the tree would grow in this position and fill up these blocks, you can see we can always push it to the side and make a room for the next tree. So for the lack of being able to make a 2x2 tree farm, what we can do, for example, is we have this funky door. And I know before you say something, yes, if you have a 2-wide door, you can just put pistons from both sides and just retract blocks. But that would make it for a very boring door. Like this one is, I think, way cooler. So we have opening sequence and we have the closing sequence. And the design is actually quite simple and it's actually quite funny. So what I would call it like a Mordor style doors. They are very easily stackable and the action is actually pretty cool. So they actually open from the bottom and close also from the top to the bottom, so the bottom part stays open the longest. And design is actually very simple. So we have here those 2 double piston extenders next to each other, and then after some time the blocks are retracted back to their original position and we have our closed door. So note here on the side, since there is no quasi-connectivity between pistons, we cannot actually rely on it to power a wall of pistons. However, it is possible because the dust actually connects to pistons. So those pistons on the same level as the dust are connected to the dust and power to the dust, and pistons below are powered through the blocks. So that's not an issue in this version because of that. And here I add a little bit of delay between each floor. Yes, you can just do it and fire them at the same time, but I thought it'd be a nice sequence to run them like that. So they run with a little bit of delay, then it's a little bit of delay at the top to actually allow us to go through, and the same torch tower going down to the bottom double piston extenders. So if we don't like the show of the redstone, here is another version that I just made. This is a little bit bigger, but it's only because we have extra space to store, in this case, open fence gates. If we press this button, it's the same thing. It opens, we can go through, and then it closes behind us, moving these blocks back, replacing open fence gates with door blocks. And yes, you might be thinking, yes, you could probably use open trapdoors here on the sides in order to push them, so we can actually have a proper way through, not obstructed by the look of the open fence gates. However, that's what I believe a bug in the game, at least with the Bedrock edition. If you push an open trapdoor with a piston, it actually updates and closes again. That's never been the case in Java. I think maybe it was once and then it was marked as not intended and fixed. Especially that with fence gates it doesn't happen. So with fence gates they stay open as we push them, with trapdoors they actually close. There's another interesting quirk with the rails. For example, here we have a little rail track. What if I remove blocks below them?